Okay, we're going to do number 29 from section 2.3 from Stewart Calculus, early transcendental, 8th edition. Evaluate the limit if it exists. This is one of the later problems, so it's one of the more difficult ones. Here what we have is a difference of two fractions. Typically what we want to do is we want to create one single fraction so that we can do some of the tricks involved. This is a difference of fractions. In fact, the limit of each of those terms does not exist. The limit as t approaches 0, 1 over t does not exist. But we'll see if we combine the fractions, we'll get some cancellations. So to combine the fractions, we just do plain old ordinary algebra, which, by the way, is sometimes not that easy. We'll do plain old ordinary algebra where what we do is get a common denominator. So the first term I don't really want to change at all, but the second one, I multiply the numerator and the denominator by radical 1 plus t. So I could change the color of that or something so you can see what I did there. But that was multiplying the numerator and the numerator and the denominator by of which part? This part here, this is the new part right here. This radical 1 plus t. I multiply the numerator and denominator so that I get a common denominator, and then I can combine those fractions. So I have 1 over 1 minus radical 1 plus t in the numerator, and then the denominator is t radical 1 plus t. Now see, if I directly substitute 0, because t is approaching 0, if I look at this denominator 1 plus t, if I put in t as 0, I get 1. That's okay. But what's not okay is this t in the denominator, because when I put t, if I put 0 in for t, I get divided by 0. That part that I tried to highlight in green, maybe I'll use red or something, or pink, that part right there, that pink part, t, that's the problem, because I don't want that in the denominator. And I'm hoping I can simplify so that I can cancel out that t there. And what happens is that there is a way to do that. So let's charge ahead. I have a radical in the numerator, and it's a difference. I have 1 minus radical 1 plus t. When we have a radical that has a difference, I can multiply by the conjugate of that difference. And I have to do the same thing to the denominator. If I multiply by something on the numerator, I have to multiply by the denominator also. And so what's happening is we're going to use the simple formula a minus b times a plus b equals a squared minus b squared. That's where we're going to use. So, all right, because we have an a minus radical, a plus a radical. So, back to the white ink, if we want to call it ink, okay. So I'm going to get in the numerator 1 squared minus radical 1 plus t, that expression squared. And we'll see that everything's going to come together. What you don't want to do is you don't want to multiply out the denominator. That's not going to be good. No, don't do that. Well, I mean, you could maybe, but especially don't multiply that t out. The t we're hoping to cancel. See again, this t, that's what we're going to cancel eventually. And we'll see it comes pretty quickly. Okay, so how's that going to happen? Because of the way that a minus b times a plus b makes a squared minus b squared, and the numerator to get 1 minus, keep the parentheses there. If we don't, it could cause trouble. We have radical squared, so the radical and squared cancel out. Then, what's going to happen? Well, let's just follow the steps, and I think we'll see that something happens. Okay? Now, the thing is, is we really need to use the parentheses and distribute the negative. See, it's 1 minus 1 minus t. What? Because we distribute the negative. So make sure that you get that minus t, not plus t, because the negative's distributed. Okay, make sure you get that. Okay, and then the denominator, nothing's really going on there, just exactly the same, so copy and paste. Okay, so canceling. I'm going to get canceling of 1 and 1. It's not really much going on there. I could just copy the whole thing over. I think I will. But I could avoid that. I could say, well, I don't really need to copy it one more time, but I guess I'll do that. I guess I'm going to copy that down, and then we'll see there's more cancellation. So I have negative t, and that's going to divide by t. Probably could have gotten away without doing that, copying that step, just canceled from where I was. But anyway, pick a good color. No, it's not that good. Anyway, cancel those t's out. Okay, and now when I cancel out, what's left in the numerator? It's t divided by t, but it's negative 1 still there. And the t was the troublemaker. Well, there is something called good trouble, but that was just the one that was not, anyway, it wasn't doing what we wanted to do. Okay. So what we're going to do now is we're going to put t equals 0 in there. So that we can do, but see, the problem is before we couldn't put t equals 0 because that gives division by 0. But now that's not going to happen. Now, once I put the numbers in, I don't write limit anymore. So you should, to show your work properly, you should be showing limit each step. Okay, each step should show limit. But once you put in the number, you don't. Okay, and then what is that going to do? Well, it's just up to us to, it's up to me to make a mistake now and get it wrong. But it happens all the time. I'm doing super good, or at least I think I am. But then at the very end, I do some blunder, get it all mixed up. Okay, but anyway, I think that's it. And how do I know it is? Because you can look at the back of the book. But anyway, just by following the steps, you can see that's the answer. Okay, so there is the whole page if you want to take a screenshot or whatever it is. That is section 2.3 of Stewart Calculus number 29. It's an odd problem in the back of the book. The answer says negative 1/2. And those are all the steps. There might be a faster way. Maybe someone else knows a way that's faster. But I did it. And I followed sort of the steps that you see of if you have a difference involving a radical, multiply the conjugate. But before we could do that, this step had one more thing to it, which is I had to write this difference of two fractions all as one fraction. So I could do that simplification trick. Okay, so that is all. Goodbye and good night.